Okay, at number 21, we are dealing with a volume problem here, and it looks like the old base of a solid problem where we pour a concrete foundation and build something out of that. So let's go ahead and draw what it is that we are dealing with right here, and we'll try to go a couple different colors right here. We've got ourselves a y-axis and an x-axis, and the base of that solid is the region bounded by, okay, I'm going to write this over here. Y is equal to the square root of 1 minus x squared. Now, I would bet a lot of people got freaked out when they saw this problem doing it without a calculator because they thought, I don't know how to graph that. Maybe not as bad as you think. I'm going to square both sides and get y squared is equal to 1 minus x squared. Then I'm going to bring that x squared term over here to get x squared plus y squared is equal to 1. Okay, and hopefully now you see it. That, everybody, is the equation of a circle in standard form centered at the origin with a radius of 1. The only thing that's tricky about this, there was no plus or minus in front of the original function. Y can only be a positive number, the way this function is written, which means we're just dealing with a half circle right here, I should say the top half of this circle here, with a radius of 1. Obviously, then it goes to negative 1 on the left, and that's the base of our solid. Okay, so there's the concrete foundation we just poured right here, including this line right there. Okay, got it. Now, what's going on? The cross sections we're going to build sticking up into the air now are squares. So, and it did say, perpendicular to the x-axis, which means our cross-sections are going this way. That is the side of a square, so I'm going to go ahead and call that S, and we've got to figure out how long S is. It's a variable quantity starting up here on the curve we had right there and ending at the x-axis. So S is measured simply by taking top function, the square root of 1 minus x squared, minus the bottom function, which is the x-axis, just 0, so I guess I didn't need to write that, and that's what S is. Now, the area of our square is side squared, so it's just going to be this quantity, the square root of 1 minus x squared, there's your side, squared. And this was nice of them. The square and the square root cancel. So area, written as a function of x, is just going to be 1 minus x squared. And as we've said all along when we did these problems in Chapter 6, once you've come up with the a of x formula, the rest of this should be relatively straightforward. Volume, then, is going to be the definite integral of whatever your a of x formula is. So for us here, that's a 1 minus x squared taken with respect to x. The issue, I think, on this problem for some people might have been the limits of integration. This function, this entire quantity region right here starts over here at negative 1, ends at positive 1. So we certainly could go negative 1 to positive 1, and that will work and it will get us the right answer, I am certain. However, I'm going to take advantage of the symmetry here, guys. If you cut this region in half, we only have to integrate it from 0 to 1, but then we have to double that result. That's going to be a lot easier than worrying about negative 1 being put into our antiderivative. So I'm going to have a 2 right here. We are going to anti-differentiate 1 minus x squared to get an x minus a 1/3 x cubed. Gotcha. And we're evaluating all of that from 0 to 1. So let's see. We've got a 2 times. That's going to be a 1 minus 1/3 when you put in the 1, and putting in a 0 is just going to get you zeros right there. So that's really all we have to worry about. 1 minus 1/3 is 2/3 times 2 is going to get us 4/3 now for the volume of this solid. So it looks like our answer for 21 is B.